This is video 2 for some of the examples that we didn't get to in class today over double angle identities. So this one, in this problem, we're going to be looking at example 4, which is at the top of the next page. All right, now there are different ways that you can do these problems. I'm going to show you one way, but if you come up with another way that sort of logically makes sense to you, then that's okay too. As long as you can show how you got your answer, and as long as you get the correct answer. I mean, you have to be able to show me how you got it, then you're fine. Okay, so what we're going to be doing here, so it says use an appropriate double angle formula to simplify. So basically what we're going to be doing is given expressions that are, when you see me do that, it means that my iPad is frozen for some reason, and I'm not sure why, and that's a way that I can unfreeze it. So basically you're going to be like working with an expression that's on this side, and then you're going to be turning it into one of these. So that's what they mean by simplify, is you're going to be given sort of the complicated side of the equation, and you want the less complicated side. Okay, so this one should kind of remind you, we've got 3 sine theta cosine theta. That looks kind of like this. So how can we handle the fact that we want a 3, but the formula is a 2? So I'm going to write the formula down here so that we have it and we can look at it. So we know that the sine of 2 theta is equal to 2 sine theta cosine theta. Okay? Now, they don't match completely, as we already said, but I do want you to notice that this is the same as this. So what we can do in this identity, remember, if this is an identity over here, then we can add the same thing to both sides, multiply both sides by the same thing, we can manipulate it. So I'm going to multiply both sides by a half, and so I end up with 1/2 sine of 2 theta is equal to, these cancel out, and we get sine theta cosine theta. So now I want you to notice that here's sine theta cosine theta, just like it's here, and it equals this whole chunk right here. So this is going to go in here, and so we end up with 3 times, and then in place of the sine cosine, we get 1/2 sine of 2 theta, which is the same as 3/2 sine of 2 theta. So that's considered the simplified version of that. Well, we used a double angle formula to simplify it. Okay, the next one, for this one, notice that this looks kind of like this formula up here. So we've got like cosine squared and then minus something, and when I look up here, I see this formula right here. So it looks kind of like that, except that this is 2 and a 1, and we have a 4 and a 2, which hopefully you notice is just doubled. So what if we factored the 2 out of here? Now you can't just up and divide both sides by 2 and get rid of that, because this is not an equation, it's an expression. So I don't have 2 sides that I can divide by 2. But if I factor out a 2, I get 2 times, and then I'll have 2 cosine squared 2 beta minus 1. Now this part, the 2 and the negative 1, should remind you of this formula right here. But now notice that this is cosine of theta, and this is cosine squared of 2 beta. Right, so we're going to do this, when we're going to simplify it, we're going to do a little substitution. So let's let u equal 2 beta. Now why do I do that? Because that means this turns into 2, and then 2 cosine squared u minus 1. And then this should remind you of the formula that is right here, except in place of theta, we put a u. So if I do the same thing here, in place of theta, put a u, I'm going to end up with that this is 2 times the cosine of 2u. Okay? Again, these two pieces together, these two pieces together, this and this, are equal to each other because this is the double angle formula. Cosine of 2u is 2 cosine squared u minus 1. All right, but now what we're going to do is put the u value back in. We know that u is actually equal to 2b, so we get that this is 2 times cosine of 2 times 2b, beta actually, which is 2 cosine of 4 beta. And so that's the correct answer for that one.